Welcome to exercise 2D video. We're looking at the multiplication and division of surds. As you might notice, I've included the red theory box over here. It is important to note that the theory one just uses our algebraic letters, the pronumerals, to represent what's happening. Now, you're actually aware of some of these similar rules already from the previous exercises, but I always include it here because it starts using language and the literacy of mathematics that can also help with understanding. So if you're just looking at making sure that it says positive numbers, B and D, that's because numbers, at this stage, we can't have negatives underneath our square root sign. So once again, for positive numbers, B and D, notice that B and D are under our square root sign. We also want to always give our answer in simplest form. So we may need to do some simplifying. That's where you need to know your square numbers. As I've suggested before, it is sometimes nice to write them on a page, 3 times 3, 4 times 4. It might help you actually answer 49. So we've just done 8 times 8, 9 times 9, and 10 times 10. These do continue on with 11 squared, 12 squared, but I kind of find the first 10 are ones we mostly use to simplify. All right, let's have a look at the first example, and we'll read up the topic. When we come to multiply two surds, we simply multiply the numbers outside, so the whole numbers, and then we multiply the numbers under the square root sign. So to make a little bit more sense, here, example, we have 4 square root 7 times 2 square root 2. We multiply the numbers outside the square root sign first, the whole numbers, then we multiply the numbers inside the square root together, and then we can look to simplify. So 4 times 2 is 8, square root of 7 times 2, square root of 2 is the square root of 14. All right, so we multiply the whole number part, that's where the 8 came from, we multiply underneath the square root together. Now the square root of 14, if we look, none of our square numbers go in there nicely, so it is already simplified. Let's have a look at example 16. Division's the same, we can divide the whole numbers outside, and then we can divide the numbers underneath the square root signs together. So 15 square root of 35 over 5 square root of 7. Notice I wrote it as a fraction. I think it's so much easier to see what you need to simplify. The number parts, the whole numbers, 15 over divided by 5, which is 3. A calculator can do this for you. Square root of 35 divided by the square root of 7 is the same as saying 35 divided by 7, square root of 5. And that has been simplified. The number parts are simplified and the square roots were simplified. Sometimes it will still be a fraction at the end. 49 square root of 21 over 14 square root of 3. Straight away I put it as a fraction. Makes it much easier to see our simplification. All right, I'm going to simplify the number part first, the whole numbers. They're both divisible by 7. So if I divide by 7, I get 7. 14 divided by 7, I'll get 2. I'll also look to divide the surd parts together. They're both divisible by 3. So the square root of 21. We can simplify this part. They're both divisible by 3, so I'll get 7 and 1. If I was to write that out, notice I've got 7 square root 7 all over 2 times 1, which is just the number 2. And that can't be simplified any further. If you're unsure about that, in the last video when we had the square root of 21 all over the square root of 3, I said that could be 21 on 3, which would make 7. So if you're unsure about the simplifying of the surds, please make sure you go back and have a look at the earlier videos. All right, moving down. Example 17 is multiply. So I have 5 square root 6 times 3 square root 10. Once again, I said you can multiply the number parts together, then you can multiply square roots together. 5 times 3 is 15, 6 times 10 is 60. Now, I need to make sure that I have simplified it. So 60, if I want to know, does any of my square numbers go nicely into 60? If you tested it out, it's going to be less than 60. The only one that could possibly be would be 4 goes into 60. So I'm going to further simplify it, and 4 times 15 makes 60. Notice I've used a square number here. That means if I was to break this up, I would have 15 times 2, square root of 4 is 2, square root of 15. And the same rule as before, my number parts could be times together. So I would end up with 5 times 2 is 30, square root 15. So this is a classic case of once I've done my multiplying, I may need to simplify under the surd. Or you could actually do it first. All right. The last example is using the distributive law. That means that we distribute whatever's out the front by everything inside. It's very similar to what we do in algebra. So 2 square root of 3 multiplied by 4 plus 3 square root 3. So the number at the front multiplied by the first and then multiplied by the second. If I was to write this out in expanded form, I would have 2 square root 3 multiplied by 4. That's the first one. And then I would also, I'm using plus 2 square root 3 times 3 square root 3. I've distributed the 2 root 3 across to both terms. Now if I'm using multiplication, the rules apply. I can multiply my whole numbers. 2 times 4 is 8. Still got square root 3 plus, got to do multiply before add and subtract. 2 times 3, so timesing the number part, 2 times 3 would be 6. Multiply the surd part. Now here's one of our rules, square root of 3 times square root of 3 is the number 3. I've just got to simplify a little bit more here. 8 square root 3 doesn't change, plus 6 times 3, which is 18. All right, tricky point there is making sure you're using the rules. Root 3 times root 3 is the number 3, and the 2 times 3 made 6, and then we're able to simplify. Might be a good opportunity to go back and review some of those rules, as when these get more complicated, we're able to recognise situations, and for some people may have been able to maybe able to see that this was the number 18. Thank you.